Hello and good day to all of you. So in this video lecture, we are going to look at the types of machine learning. Previously, we have looked at what is machine learning and why we need it. So now we will dive into type of machine learning, which is more important. So if you look at the types of machine learning, so there are mainly four types of machine learning algorithms. So first of all, we have the supervised machine learning. Then we have unsupervised machine learning. In supervised, you have to train your data with the labeling. I'm going to discuss in more detail about the supervised, unsupervised. Now we are just looking at the types of machine learning. So the third type of machine learning is also called the semi-supervised machine learning, which depends on both supervised and unsupervised machine learning. And the last one is reinforcement learning. Let's dive into in the detail of these specific types of machine learning. So the first one is supervised machine learning. The supervised machine learning is a category of machine learning that uses the label dataset to train the algorithm to predict outcome and recognize the pattern. So let's say in this you label your data. So you have this input data. We have the circle, we have the pentagon, triangle, hexagon, and rectangle. So we label these data. Let's say if the data you feel it's like this shape, so you will label it as a rectangle, circle, hexagon, triangle. So you will give input your label data into the machine, so it will train it. So now you will get it the machine learning model. So this is the actually the trained machine learning model using supervised learning. So when you give the data, you will test your data. Let's say you test your triangle and circle. So it will predict the both shapes as a triangle and circle. So very simple. And this is a simple way, like whatever you train it, it will give you the output based on your training. Also in the supervised learning, we have further two classification. So the first classification or the type of supervised machine learning is actually based on the classification, where our results sets consist of the categories. So there are some examples of that category. So either if you're inserting the data of the patient in the hospital or any type of thing, so you have to put the information either the patient has a cancer or not. So either yes or no. So you have to put the information. And sometimes you are looking for the companies and you are looking at the data, which is going to be the bankrupt in this year. So based on the information which is given into the machine. So the second type of supervised machine learning algorithm is regression, where the results are continuous value. So in that you have only yes and no, or either it can be yes, no, and also some further categories I will discuss. But in regression, it should be a continuous value. So some of the examples are given below. So the prediction of the house price. So house price will be predicted based on multiple uh, information. Let's say the age of the house, location, size, building, and different type of things we can include in that. And how long it is going to take you get a house, get a home, or something like that. So in both of these regression model, because of the results are ever changing, and we are looking for those changes. Because in regression analysis, you have multiple continuous values to predict. Based on that, you will have the answer yes or no. So further, if we look at the first type of the supervised machine learning, which is classification, so we can apply, or this is actually applied to the email. So like let's say when we have spam emails comes into your email address. So there is like input is your email, which has the text feature. Then in the classifier, which is the supervised machine learning, so based on the text, it will identify either it's a spam or not. So if it is not spam, then it goes to in your inbox, otherwise it will go to the spam folder. So the second type of image classification, in this is a text classification, is an image classification. So in this, you can see in this figure, you have the cat and dog, but it looks similar. So in that case, you will have the classifier, which is your algorithm. So based on that classifier, you will have the predicted the categories or the class. So like such as like dog, cat, or any other type of material, type of feature you observe in the figure. So the second is regression. So let's look into more detail. So let's say if you're looking at dynamic price prediction, let's say if you want to look at the tabular data and you want to predict some of the numerical values from that data based on different classification. Let's say the classification is X1, 2, 3, 4, and 5, so on. So similar case when you are going to look at the house or how much big house you will get in what price. So that is depend on not only 2 or 3 features, but there is multiple features. So based on that, we have to come up with the regression analysis. So the second example of the regression is remaining useful life estimation. So you have further analytics based on your different parameters, let's say X1, 2, 3, and 4, and you have multiple rows into identification. So let's say the output of the numerical value will be 30. So further, if you look at the comparison of the classification and regression analysis, so on the left side, you can see there are features like X2 and X1. So when you pull out your data, so it will have a different boundary. So you will have this different boundaries or the decision boundary. So based on that, you will classify either this is a class 1, this is class 2. But in regression, you have to predict the quantity. So these are actually the red dot on the data point. And this is the linear regression, which is passing through the best fit of these data sets. So based on that, you will have the decision on the machine learning output. So the second type of machine learning is the unsupervised machine learning. So this is actually an artificial intelligence is a type of machine learning that learn from data without human supervision. So how it's learned from without human supervision. So let's say if you have the unlabeled data, so you have different type of shapes here. So you give this data into the machine. So this machine will not detect either this is a circle, this is a triangle, hexagon, or rectangle, but it will classify into different clusters. Let's say this shape will be different cluster, this shape will be different cluster, and the different cluster. So it will not identify based on the name of the shape or the something, but it will make a cluster of these different things. So this is actually type of unsupervised machine learning. So let's look at further example to just make our concepts clear on unsupervised machine learning. So in unsupervised machine learning, we don't have any label data. So we don't have this one. So the data which we give, let's say in this case, we have the apple, banana, and orange. So we give this data into the machine, which is unsupervised. So based on that data, it will come up with the cluster. So the first cluster of oranges, the second cluster is of apple, the third is of the bananas. Another example, let's say if you have the raw data, which is in the form of shape. Similarly, like the previous example, so we give the input data, unlabeled input data to the algorithm, and it will classify based on the cluster, the triangle, the square, or the circle. So another example, so the input data, which in case we have different shape, the data is the same. Let's say if all is car, but based on the different features, so it will define the different clusters. Let's say the cluster 1, 2, and 3 based on the different shape or the feature of the same equipment or the same figure you have given it. So there are also different type of unsupervised learning. So the first unsupervised learning type is clustering or the segmentation, as what we discussed just now. So where the data is grouped into the meaningful way. So the segmentation involves the human defined grouping, while the clustering involves the machine learning power grouping. So like in the previous example we look at, so there is no human involved. So the clusters are defined based on the machine because it recognizing the shape of the things which has been making the cluster. So like this one, so let's say if you define different dot points, so you will define the cluster A, B, and C. But in segmentation, you have to define by yourselves. Like if you're given the picture, so it make the cluster of the people, which is in the green, a tree, and the road blue, and the buildings with light gray color. So based on that, it will not identify. The first thing is the clustering. The second thing is the segmentation. So the example here is a technique of splitting the customers into separate group depending on their attribute, behavior, make this possible. In this case, in my understanding, the clustering comes first, then based on the clustering, you do the segmentation. And the second type of unsupervised learning is that dimensionality reduction. So in this type of machine learning, where the high dimensional data is represented without the dimensional data. So this technique often used in the processing of the data where the complex input data is reduced to its most useful information carrying part. So like here, if you look at this data set, we have x1 and x2, x and y axis. So the data is dispersed. I mean, it's on the different point. So I mean, it's not related to the best fit over here. So what you have to do, you have to come up with the best fit. So let's say if this is passing here, so it's mean this can come here and this can come here. The third type of unsupervised machine learning is association. So in this type of machine learning, the relationship between the variable is a big data set is discovered. So for example, you remember the customer who bought the thing X and it will bought the thing Y. So it is actually the proportional of the behavior or the interest of the people. Based on the dependency, it will come up with the association algorithm. So in unsupervised machine learning, we have different type of algorithms. So the first type of algorithms in unsupervised is clustering, which we have discussed, the dimensional reduction and association. So we also use different type of algorithms based on the clustering, which is k-mean, hierarchical, OBS scan, optics. For dimensional reduction, we have the factor analysis, principal component analysis, PCA, ICA, TSNE, UMAP, and in association we use a priori, ECLAT, FP growth. So these are some of the algorithm we use, and in future we are going to discuss these in detail for each specific example. So the third type is the semi-supervised machine learning. So in semi-supervised machine learning is actually a branch of machine learning that combines the supervised and unsupervised machine learning by using both labeled and unlabeled data to train the artificial intelligence model for classification and regression tasks. So let's say if you have this input data, which is not labeled, but it is actually the partially labeled. Let's say you label it orange and bananas only, but the apple is not labeled. So when you give these two input data set to the machine, and it will train the machine or the model or the algorithm. When you give the input as unlabeled data, which is your apple, so the prediction will be it is an apple. How does it comes? Actually, it is coming from the prior information. Let's try to understand how does it work. So this is a flow. So what happened here? So there are two type of data, which is labeled and unlabeled data. So the data which is unlabeled, the machine will create a pseudo label data based on the unlabeled information. Then when this is the pseudo label data become the label data, then we have another data which is the pseudo label and the label data. So then we will combine it together to train the machine. So primarily train the model with less amount of training data, similar to the supervised learning. and train the continuous until the model is given accurate results. So the second thing is the algorithm uses the unlabeled data with pseudo labels in the tag in the next step, and now the results may be accurate. Now the label from the label data and the pseudo label data are linked together. So it means the data which we have given as the unlabeled and the pseudo labels, or the data which is coming from the previous knowledge of the machine. So it will link it together, because let's say in one figure you label only the orange and banana, but in the second unlabeled data you have label only the banana or only the apple. So that's why it will correlate and link together these two type of data. And the input data is labeled training data, and pseudo label data are linked together. So this is the second last stage. Then in the end, again, train the model with new combined input as did in the first step. So it will reduce the error rate and improve the accuracy of the model. So this is a way in which we come up with the supervised machine learning and unsupervised machine learning, and find the link between these two data sets and train our model. So finally, it will comes to the best model, which is using the unsupervised and supervised machine learning. So what are the takeaway from the semi-supervised learning? So in generic semi-supervised algorithms, given a data set of labeled and unlabeled data, examples are handled one of the two different ways. Either the labeled data points are handled as in traditional supervised learning, like we do in the supervised learning. Predictions are made, loss is calculated, the network weight are updated by the gradient descent. So this is one of the algorithm. Or either the unlabeled data points are used to help the model make more consistent and confident prediction, either by an added unsupervised loss term or by pseudo labels. Unlabeled examples are used to build progress of the label example. So these are the key takeaway for the semi-supervised machine learning algorithms. So the last algorithm, which is actually the reinforcement learning. So reinforcement learning is a type of machine learning algorithms or the techniques that train the software to make the decision and achieve the most optimal results. It mimic the trial and error learning process that humans use to achieve their goals. Similar way, like the human brain works, like you try to predict something, but you observe that the situation is this one or the environment is that one. Then you learn from your mistakes or these type of things. So it's like trial and error, similar to the human brain. So in this type of algorithm, so we have the input data. So input data is this one. Let's say you have the scale, static, and star. So the agent, which is the keywords here, agent, environment. So agent is actually itself is a machine, or it can be an algorithms in any type of, let's say the agent is your machine or your algorithm. So you select any type of algorithms, then you go for the best action based on the environment. So from the environment, you learn that probably this type of data, which looks like static and star, has a different feature. But when based on the feature detection, it looks similar. But from the environment, you think that these two features are different. So then you are rewarded from the environment, and you also use the observation. The observation will be stated into the machine. Then from that observation, the state of the mind, you will bring into the agent again, which is your machine learning algorithm. So based on that, you will improve the prediction. And once the data is given like this, then the output will be in the form of different three categories, like the static, scale, and the stars. So in this, actually, the keywords are more important. So agent is an entity that can perceive or explore the environment and act upon it. So this agent, which is your machine, is actually depending on the environment or exploring the environment. And what is the environment? Is actually the situation in which an agent is present or surrounded by. And in reinforcement learning, we assume the stochastic environment, which means that the random in nature. What is the action? I mean, from these algorithms, it takes the action to go the environment. So action are actually the move taken by the agent. So let's say what are the moves which taken to the go to the environments. State, which is this reward in the state. So state is a situation written by the environment after each action taken by the agent, and also the reward a feedback. So when you the agent take the action to the environment, so what will be the reward? The feedback returned to the agent from the environment to evaluate the action of the agent. Then the policy is also one of the keywords, values and Q value, which we are going to discuss. So what are the application of reinforcement learning? So the first main application is actually in the business, the gaming, and also recommendation system. And the initially also its work actually in the science. So that is actually the focus for all of us as well. But there are also some other applications. Let's say if you look at the healthcare, education, transportation, energy. So these there are a lot of application of reinforcement learning because a lot of things need the prior experience. Based on the prior experience, then the business management, science, engage engineering, and also the gaming, robotic, computer vision, finance, and computer science. On the computer system, also this one. So some example of the reinforcement learning is that to predict the text. So let's say if you want to go and write something and you want to improve the text from the previous information, so you predict the text and you improve that one. And sometimes when you're looking at the summarization of the text, so you have a lot of long, so you want to make a summary, like the AI tool also do like that. And the question answering is also one of the reinforcement learning because based on the input, you learn from the previous example or the previous environment to improve the answering to the question. It's not talking about yes or no question or the MCQs, but the answer which is based on the long text. And machine translation, I mean, there is a lot of algorithm which you use machine translation. Also the natural language processing. So if you record a video or if you have a text in different language, so there is a lot of many machine learning algorithms which use the reinforcement learning to translate that language into the other language and also learn from the previous experiences. So, what are the key takeaways about the reinforcement learning? So, reinforcement learning is one of the most interesting and useful part of the machine learning. In reinforcement learning, the agent explores the environment by exploring it without any human interaction. And also, it is the main learning algorithms that is used in artificial intelligence. But there are some cases where it should not be used, such as if you have enough data. If you have enough data, you don't need the mistakes or you don't have to learn from the mistakes. So if you have enough data about that specific part of the science, then you can just use that one and you use the supervised machine learning. Then the machine learning algorithms can be used more effectively. So if the last point is the main issue with reinforcement learning algorithm is that some of the parameters may affect the speed of the learning, such as delay feedback. Because if you ask a machine learning to learn a lot from the previous experiences, then it might have affect the delay in the feedbacks. So that is actually the normal problem when you have a lot of data in the memory. Okay, well, that's all. I hope you have enjoy this lecture, and also you have learned different type of machine learning algorithms. In further lecture, we will be dive into multiple methods in the supervised machine learning, unsupervised machine learning, and also the reinforcement learning further. Okay, keep tuned and thank you so much and have a good day.